Welcome to This Explainer. Okay, we're diving into something today that sounds like pure science fiction, but it is actually becoming an urgent economic reality. We're looking at Meta's mind-bending pivot to space-based solar power. I mean, imagine beaming the sun's energy directly from orbit to power artificial intelligence right here on Earth. It is a massive leap, and the structural implications for global power markets are absolutely profound. Here is the roadmap for our explainer. We're going to hit the AI energy crisis, orbit-to-grid solar, that wild 100-hour battery, space lasers and public fear, the global space race, and finally, the vertical energy era. Let's get right into it. All right, part one, the AI energy crisis and terrestrial grid exhaustion. To understand why anyone's looking to the stars, we've got to ground this in a very stark, earthbound problem. Just look at this number, 160 gigawatts. That is the pipeline for large load energy requests in the US alone for 2025. That's roughly 22% of total peak demand. And because of incredibly sluggish federal queues and multi-year delays for new transmission lines, waiting on the traditional grid, that's just no longer an option for tech giants. So we have to grasp the sheer scale of the appetite here. By 2024, Meta's data center operations were already chewing through over 18,000 gigawatt hours annually. And with this generative AI boom, the International Energy Agency is warning that data center power consumption could literally double globally by 2030. To put that plainly, scaling AI means consuming so much fast, firm energy that it's threatening the stability of the power grid you and I rely on every single day. Which brings us to part two, orbits to grid solar power and the mechanics behind it. So how exactly do you bypass the ground grid? Well, you build a vertical transmission corridor right from space. This is an innovation Meta is developing in a really high-stakes partnership with a startup called Overview Energy. Physically speaking, orbital solar is just infinitely superior to ground-based farms. On Earth, solar gives you what, a 25 to 30% capacity factor? Because, the sun sets and weather happens. But up in geosynchronous orbit, you're looking at 24/7, 365 continuous operation. That yields 5 to 10 times more energy per unit area. Up there, you literally don't have to worry about a cloudy day ruining your power supply. Free from all that atmospheric absorption and scattering, you get a near-constant, incredibly rich stream of solar irradiance, about 1,366 watts per square meter. The satellites only enter the Earth's shadow for super brief periods around the equinoxes. So it's this completely untapped gold mine of continuous energy. But, of course, capturing energy in space is really only half the battle, right? You still have to get it down to Earth. And Overview Energy's defining architectural choice here is near-infrared, or NIR, laser beaming. Now, this is a high-precision wireless power transmission method that purposefully avoids the microwave frequencies favored by a lot of older legacy concepts. Because NIR operates at wavelengths similar to fiber optic communications, it allows for highly targeted energy delivery without that massive beam spread you get with microwaves. The real genius here, and the main thing you should take away from this, is the compatibility. This NIR beam is actually designed to be absorbed by standard commercial photovoltaic panels, the exact same ones sitting in utility-scale solar farms today. This means Meta can just retrofit existing solar assets, allowing them to generate electricity at night. It maximizes ground hardware that would otherwise just be sitting idle in the dark, entirely avoiding the need to build massive new receiving antennas. Plus, the beam itself is engineered with a low-intensity profile for passive safety. Let's look at the roadmap to see how this builds over the next few years, because this isn't just theory. Back in 2025, they validated the tech by beaming power from a moving Cessna aircraft at 16,500 feet to a ground receiver. That proved they can track and beam right through the atmosphere. The next major milestone? An orbital demonstration in 2028. If that works out, they're targeting 2030 for commercial delivery, aiming to supply up to a full gigawatt of orbit-to-grid energy directly to Meta's data centers. All right, moving on to part three, the 100-hour battery and ultra-long duration storage. Now, capturing continuous orbital energy is phenomenal, sure, but integrating it into a terrestrial grid requires a massive buffer to handle any potential eclipses or huge spikes in AI demand. If we compare standard lithium-ion batteries directly against the tech Meta is using from Noon Energy, the problem becomes super obvious. Lithium-ion is great for short-duration peak shaving, maybe 4 to 8 hours, but that is physically ill-suited for sustained power delivery. Meta's partnership with Noon Energy, on the other hand, targets over 100 hours of continuous sustained power. So how exactly do they achieve 100 hours? It's through a technology called reversible solid oxide fuel cells. I know,
It sounds like a mouthful of complex chemistry, but just think of it as a closed loop. During the charging phase, orbital energy electrolyzes carbon dioxide into solid carbon and oxygen. Then, when power is needed, they just recombine them in the fuel cell to generate electricity, releasing the CO2 right back into the closed loop. It creates this highly reliable 24/7 baseload renewable profile, completely bypassing the intermittency of ground-based wind and solar.
Which leads us to part 4, space lasers and public fear, examining the societal pushback.
Look, when you announce that you're building literal space lasers, the public reaction is going to be exactly what you might expect. Sentiments tracked across digital forums reveal some pretty deep techno-anxiety. Critics often point out that this gives off major SimCity vibes, referencing those video game disasters where orbital beams accidentally set fire to entire cities. And there are very real public anxieties here, ranging from concerns over the militarization of space to conspiracy theories framing these gigawatt-scale lasers as directed energy weapons or even weather manipulation tools. To impartially address these concerns, Meta and Overview Energy are leaning heavily into transparency and institutional credibility. They point out that the near-infrared beam is passively safe, totally invisible to the human eye, and mathematically engineered to never exceed the intensity of natural midday sunlight. And to reassure the public that this isn't some sci-fi superweapon, they've packed their advisory boards with high-profile institutional experts, including former NASA administrators and federal energy officials. Meanwhile, there's another very real, totally non-conspiratorial concern we have to mention: the astronomy crisis. Scientists are warning that the immense solar arrays required for space-based power are inherently reflective. So even with an invisible energy beam, the physical structures themselves create massive light pollution. NASA-led studies actually suggest this rapid proliferation could impact up to 96% of images taken by major observatories. This is leading some experts to fear it could fundamentally end deep space, ground-based astronomy as we know it. Okay, part 5, the global space race, a theater of competition. While these public and scientific debates are raging down here on Earth, a fierce space energy race is quietly unfolding right above the atmosphere. On the national stage, China is aggressively pursuing space-based solar power. Analysts are actually comparing their planned kilometer-wide orbital solar array to the Three Gorges Dam for the energy sector. China already controls over 50% of the terrestrial solar market, and they are leveraging that massive manufacturing advantage to pursue absolute energy dominance from orbit. And the private sector is just as fiercely competitive and fragmented. Meta and Overview are targeting geosynchronous orbit using lasers. But check out the alternatives here. Etherflux is aiming for low Earth orbit with this radical strategy to actually co-locate AI compute nodes directly on the satellites to just bypass transmission entirely. Then you have Virtus Solis using a highly elliptical Molniya orbit and microwave transmission via mass robotic assembly. And Space Solar UK is chasing a massive gigawatt baseload using microwave tech. Everyone is betting on a different orbital architecture, with some aiming for demonstrations as early as 2026. Finally, part 6, the vertical energy era, navigating the uncharted future. Getting to that 2030 commercial delivery date is blocked by a seriously uncharted landscape. The regulatory, environmental, and financial hurdles are monumental. First off, you have to convince the ITU and FCC to map out frequency and orbital slot allocations in an already highly congested space environment. Then, you've got to prove this is actually a green technology, despite the massive emissions from thousands of rocket launches. And perhaps most severely, there's the risk of Kessler syndrome, the terrifying threat of catastrophic orbital collisions generating debris that could wipe out multi-million-dollar satellite arrays in an instant. So why do it? Why take on these immense risks? Well, it all comes down to a concept called bypass economics. Meta is not seeking the cheapest kilowatt hour. Space solar is currently way more expensive than ground-based solar, but Meta is seeking the fastest megawatt. They are incredibly willing to pay the massive premium upfront costs of space infrastructure just to secure firm, reliable power for their AI clusters, completely bypassing those 5 to 8 year terrestrial grid delays we talked about earlier. It's essentially a giant insurance policy against grid volatility, which leaves us right here. It is a high-risk, completely unprecedented gamble that poses a profound question for all of us. As we transition into this uncharted vertical energy era, will the sun, that massive fusion reactor in our neighborhood, finally be harnessed from space to become the ultimate perpetual battery for superintelligence? Time, and perhaps the night sky itself, will tell. Thank you so much for joining me on this explainer. Stay curious and keep looking up.